Hello everyone, this is Huang. Our two projects. First one is the Outlier detection project. Here I will just get some updates about this project. So our project starts with AI CPA and K-square AI. So we start from the comprehensive literature review. And then we try to find some of the public available and popular packages as well as algorithms that can be used in the Outlier detection. And then we test these algorithms and packages with two client data in Holland, and we find there's large discrepancies exist with different methods. So we want to expand our experimentation with more public data as well as some synthetic data. And then we want to find some of the solutions for these large discrepancies. Here we have two potential solutions that we're working on. First one is the in-symbol analysis, means we want to assemble the results from different algorithms and then to obtain a better performance for the Outlier detection. Another solution is subspace learning, means for the customers, they have different product lines or brand or something like that. So their data are different. So if we treat all the data the same, the performance will not be very accurate. So here we try to use the subspace learning to fix this issue. And then the next step is we will evaluate our method with real engagement data and try to develop the guidance for the auditors. So this is Outlier detection project. The second project is channel stuffing detecting models. So usually the channel stuffing means the companies they are shipping excess inventories to the downstream channel to accelerate the revenue recognition at the period end. So it's also a type of revenue manipulation, and usually motivated by the meet the target to earn the bonus or the compensations. So why this channel stuffing issue matters? Because both the regulators, the management, as well as the auditors, they are concerned about this revenue recognition issues. For example, the SEC, it has released a lot of administrative proceedings as well as complaints regarding complaints that involve this channel stuffing issue. You can see from this table, a lot of complaints, they are fined a huge amount of money because of this channel stuffing. Like they offer their customers extended credit terms or have a discount or extended the return payment or something like that to accelerate the revenues. And also this channel stuffing also have some significant side effects on the company itself. For example, it will harm the long-term profit, destroy their customers' loyalty, or bring some company a huge amount of fines within before. And also for the auditors also concern the correctness of their revenue recognition. So that's the reason we want to, the management as well as us, we want to develop a continuous monitoring model to detect the unusual sales activities to ensure that their revenues, especially the sales-related revenues, are correctly recognized as well as recorded in the right period. So our model utilizes both the statistic analysis as well as the Outlier detecting approach. And we select the order-to-cash process to build this model. And the big contribution here is that first, is enhance the complaints monitoring process and improve its internal control, and integrate the statistical analysis as well as the machine learning to provide the management with a state-of-art decision model, and it transforms the existing ex-post audit to the ex-ante supervision. So here is the architecture of the model. So we have 4 layers. The first layer is the general sales volume analysis. And then after identify the abnormal sales volume, we will do the reasonable evaluation on this on the first step results, because not all the abnormal are caused by the channel stuffing. So we need to have this subjective decision to make sure to exclude the abnormality that's not caused by the channel stuffing. And then for the third layer, we will focus on the customer level analysis, because all the fraud are employed by the customers. So we will have a detailed customer analysis. And last layer is the validation. So here is an example of our implication. So here we choose the sales volume instead of the sales price. The reason is that the sales price fluctuates significantly. And also, this is a multinational company. So the currency difference is also an issue to compare between different countries or different markets. So here, the sales volume is a more robust and standardized proxies. And then we, because different markets, they are very different from each other. So here we only compare the sales volumes of a country within the country itself. So we calculate the outlier scores for all the countries around the world. We obtain, we aggregate them based on the room level as well as the country level. As we can see here, room B here has the highest outlier scores, and then followed room C and A. So here is our first step result. And then for the second step, because as we mentioned, not all the abnormalities are caused by the channel stuffing. So here we need to do the subjective.
You have 1 minute left.
Okay, thank you. So here, for example, like we can see from the left figure, the year 2020 and 2021 had the highest score, but this is caused by the pandemic, because a lot of countries are shut down at that time, and some countries have very long shutdown period, but some countries have a short shutdown period. So this makes their sales volume fluctuate. So here we choose the 2019 as our target year. And also room B has the highest score, and also the market importance is also very high. So we choose the room B and the year 2019 as our target to dive in. And then for the customer level analysis, we mainly analyze the sales discount and sales return related. We assign each of the customer risk scores based on their customer, their discount ratio, return ratio, and the time they have this discount as well as return. And then as we can see, some of the customers, they have very high risk scores. And the next step is the validation. We compare the result, the ultimate detection result with the abnormal sales volumes that's identified by the management. As we can see here, actually our algorithm, especially this two state-of-the-art algorithm, has a very good performance, and our in-symbol results has even better performance. And here for the customer level validation, we choose we randomly select 5 customers from each of the risk level and ask the management to help us to validate it. And the result shows us that all the high risk identified as high, and then the medium risk identified as a moderate risk and may not need further investigation. Well, for the lower risk that we identified, the customer also review them as low risk. So in conclusion, our model is effective, and it can enhance the management internal control as well as the compliance procedures, and transform the ex-post audit to the ex-ante supervision. So that's all about this project. Thank you.